Welcome, Pioneers. This is our second geometry video on logic. I picked a problem that tries to encompass all of the topics we're learning in logic right now. What I'm going to do is I'm going to present to you a conditional statement, or an if-then statement, and we want to find out its converse, inverse, contrapositive, biconditional, and also get some practice with some of our other buzzwords that we have some symbols for now. Let's get started. We have our conditional statement already. This is usually what's given to us. We know that in a conditional statement, we have two parts. Our hypothesis, which usually we underline and call P, and then we have our conclusion, I am awesome, which usually we'll call Q, and we circle it. So our conditional statement is, if I like math, then I am awesome. Now, to use this conditional statement in symbols to make our lives easier as a shortcut, we would say P, and then for all if-then statements, we use this arrow, so P implies Q, or P follows logically to Q. Great, so that's the conditional. The converse is we switch the hypothesis and conclusion. If I am awesome, then I like math. Then I like math. We've switched. So now, we started with Q, and we have an if-then statement that goes to P. Great. Let's do the inverse, or negate. Negate means do the opposite, or the not form of the conditional. So we still start with P because we don't switch, we just negate. So we say, if I do not like math, then I am not awesome. Okay? Now, when we negate, to symbolize that, well, we started with P, but the opposite of P, so we do that little squiggly line. And then we still have an if-then statement, so I'm going to put the arrow. And then we said the opposite of Q. So not P implies not Q. That's the inverse. Contrapositive. We switch and negate. So we switch just like the converse, so we start with the awesome half, but we say not awesome. If I am not awesome, then I do not like math. Okay? So let's see what we did there. We did not Q, because awesome is Q, right? We said awesome was Q. So we did not Q implies, because we have an if-then statement, so we need that arrow to symbolize implies, or if-then, not P. Then the biconditional, this is our if and only if statement. So we do, I like math, if and only if. That's a shortcut for if and only if we learned. I like math if and only if I am awesome. Notice how this is not an if-then statement like all the other ones were. It's not if-then. So when we symbolize this, we just have normal P and normal Q, but they're not joined by a normal arrow like in if-then statements. This is joined by a two-sided arrow. It almost looks like a line, right? We learned that lines are those segments with the arrows attached to it. Lines extend indefinitely. So, P, if and only if, Q. And then lastly, this is just some practice for some three buzzwords that we have some symbols for. I like math. And then we don't do if and only if. We can either plug in therefore, or and, or I am awesome. So we could say, I like math, therefore I am awesome. I like math and I'm awesome. Or I like math or I'm awesome. And how would we symbolize this? Let's remember our symbols. Well, the first part is P still. Therefore is these three dots in a triangle formation where there's only one dot at the top and two at the bottom. And finally end with Q. We could say P and Q. The and symbol almost looks like an A. Or P or Q. Or the caret goes the opposite way of and for or. So P therefore Q, P and Q, P or Q. Okay, so we not only started with the conditional and wrote the converse, inverse, contrapositive, and biconditional, we also used our symbols to symbolize this logic, which is a nice shortcut. And we practice therefore, and or. I hope this helped. Let me know if you have any additional questions.